Thanks for getting up. My alarm went off as we were sitting here, so that tells you when I normally get up. So I appreciate the effort that you've made. So I'm going to talk to you today about words, and I'm hoping that you'll learn something about words and maybe learn a little bit about the challenges that we face when we're trying to make sense of words that are out there. And because I wasn't entirely sure about the sort of range of knowledge in the room, I'm going to keep the talk fairly conceptual, but I hope it inspires you to go out and maybe think about how you could take more advantage of words that are data in your context. So I'm going to tell you some stories that might make you go, oh, too hard, and hopefully give you some ideas of how we do try to approach that difficulty. So, so without further ado, I guess I'm going to state the obvious. Words are everywhere. So this really is sort of the primary motivation for why we want to try to deal with words and try to think of words as data. So in every interaction we do in most of the literate world, we use words. And the thing we have to remember about words is that they're really not intended as data, right? We're not producing these words in order to make an algorithm happy. What we're doing is we're producing these words in order to communicate with each other. So it's the way that we interact with one another. And that means that words are intended for human consumption and not computer consumption. And that creates a lot of challenges for us as in trying to deal with those words. So, but you know why? So why bother? Because words are meaningful. They convey meaning. That's the whole point of putting words together into sentences, and you coming here to listen to me is all about trying to extract information from these words. And I'm bothering to put words together because I would like you to learn something from my own experience. And the only way that I have to convey that to you is to put them together into this natural language. So if we take a look at one of the most obvious sources of words that we have these days, we might look at Twitter. So let's look at a few tweets, and I'm sorry if these are quite hard to read. So here we have a tweet about this phone, this new phone called the OnePlus. China's hottest phone, here's the upstart chasing Xiaomi, and then there's a link to an article. So this one feels pretty positive, right? This is a great phone. It's the hottest phone. You want to go and get it, maybe. Well, if we look at another post, when all of your friends have an iPhone and with new emojis, and you're still using the old set, Android girl. Now, what do we think about this one? Does she like her phone? Maybe, maybe not. It's hard to tell. There's a little bit of ambiguity there, isn't there? What about this one? Don't buy this boogie phone, facing a hell lot of issues. Now we've got spelling mistakes. We've got clearly negative feedback on this phone. But then he says, "Oh, available invite free today." So he wants people to buy the phone, but then he doesn't want people to buy the phone. Okay, that's interesting. Oh, here's another one. Net the 1 + 1 bestellt. Top telephone. A power user's dream and excellent value for the rest of us. Okay, so what's going on here? We've got words. Words anybody else understands? No, Dutch words. And mixed with English, right? So when you're dealing with Twitter, this is what happens. You get languages mixing together. And for people who live in very dynamic linguistic environments, places where there are multiple languages that are sort of commonly spoken in that environment, this is an extremely common occurrence. And so there's been a whole effort around trying to do language identification in tweets. And they work well when all of the words in a single tweet are consistent. They work less well when you have this sort of thing where there's mixing going on. People are trying to deal with that. By the way, that's a positive tweet. Top telephone, you can figure out top telephone, right? Maybe. Here's another one. OnePlus, don't troll and bully me. Where's the freaking update as promised? Premature announcement, tall claims. All right, this guy's clearly angry. However, he's not angry about the phone, right? He's angry because his update hasn't arrived on time. So he's impatient. But if you just look at the words, it feels negative, it feels angry. And so again, we have this ambiguity. Words are complicated. He's saying one thing, and he is angry, but he's not angry about the phone. He's angry about the lack of update. He's anxious for his update, right? Sometimes I'm surprised at the kind of images I can produce with my 1+1. So that's a very positive tweet. She's surprised. I think it's a she. She's surprised by something, but surprise is something that can actually go both ways, right? It can be a positive thing or it can be a negative thing. And so we're inferring that the images that she's happy with the images that she's producing, that they're surprising in a positive way. But it requires a lot of inference, and I think that's one of the key things to remember about text is because we're trying to communicate from one person to another, we're actually doing a lot of inferring about where they're coming from and how we interpret what they say. It depends a lot on our perception of where they're coming from in their worldview. Okay, so I hope this gives you some sense of the complexity of dealing with text. So how much do you deal with text? So one of the things that people have been doing lately that you see a lot of is these word clouds. Anybody seen these before? Yeah. So the representation in a word cloud is pretty simple. They basically the tools that build these things go and they count the number of words. They break the text up into words. They count how many of them they are. And bigger means more frequent in the text. So I went to another place full of words, Reddit, and found this sort of this Reddit that was marked as controversial. I thought controversial was good. So the title of it was this: Adam Sandler has made some crap movies recently, but The Wedding Singer makes up for those. And this generated a whole bunch of conversation on Reddit. And this word cloud summarizes all that conversation. And we see words in there. We see good, we see fucking, we see remember, we see song, we see Adam, we see point really big. I don't know what that's about. Wedding, of course. Sandler, apparently one of the most frequent words in there, which makes sense. And so on. I deleted a bunch of usernames, although there's still a few that are in there. So what can we learn from this? People agree with this guy or not? Who knows? Okay, so what we've done is we've taken the words, we've looked at the word frequencies, we've lost all the context, we've lost the structure. We don't have the dialogue in there. We can't see who said what, which person used which words. We've lost the whole structure by doing this. But in fact, this is basically what we do with most of our algorithms these days, is we take the text and we get rid of all that complexity and we boil it down to word frequencies. And I sound like I'm being critical of that, but actually it gets us a really long way of just getting getting a sense of the information that's communicated in there. Okay, but let's bring in some algorithms. So who knows how we might try to get a sense of whether this is whether people agree with this guy or not? Anybody think of a method? I'm sure you've heard the buzzwords for how we might interpret these words. Anyone? Yes.
There are two methods I will mention. One, the other one I can't remember. I'm thinking of stuff. I use the PCA.
Sure.
To try to see kind of theme.
Yep.
And to base on that to identify the direction.
So she's mentioned primary components analysis, which is a method for basically trying to reduce the dimensionality of a very large dimensional space and trying to find the sort of primary component, the primary information in there. Sure, and that would be one approach to doing that. And yes, you have another one.
Second one, yeah, I just remembered sentiment analysis.
Correct, yes, so that's what I was looking for actually. So sentiment analysis is a really popular technique for trying to boil all of those words down to some measure of positivity or negativity. And typically most sentiment analysis algorithms try to represent the meaning or the sort of the sentiment of a text along two dimensions. One is subjectivity, so how opinionated is the particular piece of text we're trying to analyze. And in this case, for that Reddit text, it came out as extremely polar using a demo that's available online. And then we have the type of polarity that's being interpreted. So it can be positive or negative. Now, look back at these words. So what's the biggest sort of sentiment-related word that we see here? I would argue it's Good, right? So one might think, just looking at the word frequencies, that this is overall a positive sentiment is being expressed in that text. But this algorithm, for whatever reason, came out with negative as being slightly stronger. And again, it's because we're trying to boil down all of this complexity into, in this case, 4 numbers. And it's difficult. But it gives us some sense that there is at least emotion and subjectivity and going on in this text, which can be valuable. Okay, so let's get down into some linguistic examples, because I think it makes language real when you think about the words and how we use them for our purposes, not for computer purposes. Okay, so they poured the wine into the and drank among friends during the meal. What's mean? Anybody guess? Glass. Anyone else? Cup. I've primed you because I put a glass there. But it's actually pretty easy to tell what this might mean, at least have some sense of roughly what it might mean, just by looking at the words and the context around it, right? If I hadn't put the glass there, you still would have told me glass, I think. Do you believe me? Maybe not. So this is how we learn language, right? We do a lot of reading, we encounter words that we haven't seen before, and we look at the words around them, and we kind of build a representation of the relationships between words in order to get a sense of how they fit together and what the word might mean. Now, in real life, and how people do this is we're grounded in the real world, and we do have cues, like visual cues, that we can use to help us make inferences. And that's a huge part of how children, for instance, learn languages. And learn things like the meaning of a verb. There's a guy named Steven Pinker in the US who's done a lot of work on that. It's very interesting. So the point here is that no word is an island. Words live in the context of each other. And there was a model that was developed in probably the 60s, I think, that tried to capture this representation, the sort of this idea that words live in the same kind of space together. And this is called the vector space model. And basically, the idea behind the vector space model is that you can plot words into a high-dimensional space, and words that go together in certain contexts will be close to each other in that space. So what I've drawn for you here is, okay, we have a vector for wine, and we have a vector for pour, and we have a vector for drink, and we have a vector for cup. And this represents to us all of the sort of relationships that these words have to each other, and I'll actually show you how we build this in a second. And so we have this word, participle. And if we look at the words around participle, we can figure out that it's probably pretty close to cup or to glass, if you like. And so technically, we can build a model like this which allows us to sort of identify the meaning of these unknown words. So what does a model look like? It's very simple. And obviously, I've oversimplified here. We're going to actually, you can put word frequencies in there and you can normalize them in various ways. But just the basic representation that we have is to look for words and documents in this case. And we can just look which documents an individual word appears in. And when we build this representation, we actually find that words that occur in the same documents will share elements in this representation. And so the more documents that a given word has in common with another word, the more similar they are. Okay, and we can just do very simple cosine, just measure the angle between these vectors, and that gives us a measure of the similarity between them. Does that make sense? So it's a really simple model. And I've done exactly what I just scoffed at, boiled it down to individual words, got rid of all of the structure. But it gives us a tool to help place those words in the right semantic space. This is what we call the bag of words model. So we break our documents down into bag of words. We literally take the text apart, throw the words into shopping bags, and just shake them up, and that's what we have. And you can add probabilities over this, and that's what a lot of the work in natural language processing is really about, trying to get that. Okay, so But I've told you we've gotten rid of the structure by doing that. And what do we lose by doing that? So one of the important things that we fail to capture in that kind of representation is relationships. So it matters what order we put these words in, at least in English. English is a pretty strictly ordered language. So Mary is quicker than John. That means the opposite of John is quicker than Mary, right? And what if we change the word? Mary is slower than John. So actually, Mary is slower than John means the same as John is quicker than Mary. How can we figure that out? It's tough, right? We need to take advantage of the syntactic structure of the sentence in order to do that. And there's been a whole series of activities in the natural language processing community about trying to figure out what the syntactic structure of a sentence is, trying to work out what the main verb is, trying to work out what the relationships between them are. Now we can combine this with something like that vector space model in order to figure out that quicker and slower are related to each other. Could we figure out whether they're antonyms, if they actually mean the opposite thing? Be tough in a vector space model, wouldn't it? Because they're actually very commonly occurring in the same context. So figuring out antonyms is something that we do naturally, but that the computer models really have trouble with. Okay, so this is trying to motivate that we might actually need to look at a little bit more structure. Again, if we boil things down to this vector space model, we've just lost that completely. We've lost that structure, and you can see this because the vectors for our two sentences, which have the opposite interpretation, right, are identical. They have exactly the same words in them. Okay, so let's talk about another problem we face, lexical ambiguity. The bank is covered with flowers. What kind of bank are we talking about? A river bank, probably. I have an account at that bank, the place where you keep your money. The bank is covered in vines. Well, that one actually could go either way, right? I've shown you a picture of something like a building covered in vines. So again, I primed you to one interpretation. There was a run on the bank. That one's really tough, right? Again, it can go either way. And I think we need that context. We need more context in order to be able to resolve that. These are tough for people out of context. So now I'm going to show you another bank that has vines on it. So that, just to emphasize that, you know, the bank has vines, or is covered in vines, or whatever the sentence was, is covered in vines, can have multiple interpretations. Again, our vector space model actually gives us a way into trying to resolve this difference. So if we look here, we're gonna, you know, we look at the common relationships. So bank in the money sense will tend to go with words like money and account and deposit and things like that. And bank in the other sense will tend to go with words like, I don't know, picnic and water and river and things like that, right? And so by looking at the distribution of the words across different documents, we can actually get a sense that, oh, there's multiple contexts in which this particular word is being used. And that's a strategy that's used by a set of algorithms that kind of fall into a problem space called word sense disambiguation, where they essentially try to look at words that have different contexts of use and trying to separate those contexts out. Okay, another problem, syntactic ambiguity. They're hunting dogs. Actually, I should let you read them before I say them, because when I say them, I actually am giving you hints about how to interpret them. So there's two, do you see the two interpretations of the sentence? They are hunting dogs, right? So these dogs are a particular kind of dog, they're hunting dogs. Or if I'm talking about, you know, guys who are out to go kill dogs, they're in the process of hunting these little animals. You see it? A bit tricky. These things happen all the time. You don't even notice them. You resolve them immediately because you bring your context to bear. Okay, do we like this one? So I intentionally chose an image which obviously would prime you to the maybe non-standard interpretation. So this was a real headline. Okay, people help dog bite victim. Great, thank you, people. Good Samaritans that you are. Very lovely. Police help dog bite victim. The other interpretation of this is clearly that the police are helping the dog to attack this poor person. Bad police. Here's another one that you find in sort of every linguistic textbook. You see the ambiguity? Okay. We've unfortunately seen quite recently a very good example of why flying planes can be dangerous. The act of flying a plane itself can be dangerous. But of course, if you're sitting on the ground and there's some low-flying planes, you're going to have the other interpretation of the sentence, right? The man watched the woman with the telescope. What do we think? Do you see the two interpretations? All right, he's watching through, the man is watching through the telescope and he sees the woman, or the woman is walking around with the telescope. So these things happen all the time. I said I'd be there on Thursday. Do you see the ambiguity? It's the saying that happened on Thursday, or the being that will happen on Thursday. Okay, so this is called a prepositional phrase attachment ambiguity. So linguists love these things. Why? Because they confuse our ability to understand the language. It makes it hard for us, and by the same token, they pose challenges to our algorithms. Maybe you don't care about this sort of stuff. Maybe it doesn't matter which interpretation for a particular task, but maybe for some tasks it's actually important to distinguish and get the right meaning out of it. So here's another few examples. Said the elderly woman to her aide, "Can you roll my wheelchair to the window?" Now, literally speaking, the correct answer to this question is either yes or no. But that's not what's meant by this sentence, right? Can you roll my wheelchair to the window? That's a request. It's a request to be moved to the window. And the appropriate response in terms of conversational interaction is that her aide moves her to the window. Said the man to the waiter, "This coffee is cold. What's going on here?" It's just a complaint, right? No, it's not just a complaint. It's an implicit request again. Replace my coffee, give me fresh coffee. And so when we're trying to extract meaning, we have to keep in mind that a lot of our communications are very complex and are really about trying to engage with our environment and change our environment in various ways. Okay, we're gonna laugh a little. All right, so this is from the Pink Panther. The scene, anybody know the scene? Good, more fun this way. All right, so Inspector Clouseau looks at the dog. "Does your dog bite?" he asks. This is in a hotel, I think. The hotel clerk says, "Nope." So he reaches down, he pets the dog. The dog bites him. Anyone guess what happens next? "I thought you said your dog didn't bite." Language is fun. So when we interpret language, we bring a huge amount of assumption and social rules. There's a whole set of these rules that have been canonicalized as something called maxims, Gricean maxims. A guy named Grice proposed these things. And these rules govern how we interact with each other. And they actually control, at a theoretical level, I'm not talking about a little guy in your head controlling what you do, but they affect what we say, what we don't say, how much context we have to provide. I thought you would like that. Okay, so the set of techniques that are being developed to try to deal with these problems fall under the rubric of natural language processing. And there's a whole bunch of tasks and types of problems that people have been working on. And many of the examples I've given you today are being dealt with in various ways. So information extraction is about trying to find entities, perhaps ontology concepts or specific controlled vocabulary terms, relations and events between them. word sense disambiguation and sense induction that's trying to deal with that lexical ambiguity, sentiment analysis we talked about, document summarization, text classification, topic modeling, machine translation. All of these things are sets of algorithms that build on the idea of trying to make sense of text at one level or another. And I could give you a talk for hours about any one of these. There's a huge amount of work that's been happening in the discipline. Let me give you another motivating example. So this is a picture of an electronic health record system, a product that's being pitched by a company. And they say in the review, or there was a review written about it, and it says, this system is designed for physicians to point and click their way through an entire exam quickly and effortlessly. Yay! Thank you for this lovely tool. So what do these physicians have to do? They have to, for every single thing they want to say about a patient, they have to find a drop-down menu, and they have to scroll down and find the right term, and they have to fill in a few structured fields, like maybe the blood pressure of the patient. Fantastic, great. I personally am really excited about the fact that we're capturing all this information electronically. But there's a little problem. How far down do you think physicians scroll when they go searching for their term? Which terms do you think are the most frequently accessed? The first 5, right? There's huge biases in these kinds of things. So why not just let the physicians write the words down? So they do that. They write these clinical narratives. And if we compare this with this, we see that the clinical text has nuance and subtlety and huge amounts of detail that there's no way you could anticipate, no matter how sophisticated your electronic health record software is. Now, I'm not saying don't have structured data entry. Absolutely, it's a useful thing. It gives us a heads up. Why ask people to write stuff that is structured? Put in a BP in a number field. BP being blood pressure, sorry. Put that in a number field. That's great. It's quantitative data. Quantitative, computers know how to deal with that. Let's use it. Don't need to do extra work to try to get that information. But for a lot of the information that's in here, we can't anticipate it, so it needs to be allowed to be written in the natural way that we communicate and record information. Now we can do things with this. So we can identify particular types of terminology and phrases that are relevant to understanding the content of this. So I've gone and highlighted a few terms that you could probably pick out using a dictionary even. So shortness of breath might be in a list of symptoms that have to do with medical information. Breathing treatments, dyspnea, morphine, and so forth. So we can find these things. But the details of some of the information in here is really quite difficult to capture. So the concept of progressively getting worse, this is actually a temporal piece of information, right? So what this tells us is the patient started off not doing so well, but actually over time has gotten worse, right? And progressively implies that it's been a gradual decline, not a sudden decline. And that actually might make a difference in terms of diagnosis, right? It might matter whether the patient was well yesterday and just completely unwell today, or whether it has been this sort of deterioration effect. How can we anticipate that in that structured data entry? So for every single linguistic concept, like progressively or mildly, are we going to have some sort of drop-down menu? I don't think we can do that. So we really do have to dig into the words. Okay, so I think I've given you some idea about the challenges maybe, and some easy ways that we do deal with text and can deal with text. And I'd like to just mention that this gives us, there are some huge opportunities out there for taking advantage of text, and we see this happening all around us right today. So social media analytics is obviously an extremely hot area. Predictive analytics from text, there's lots of work, including in the research world, that's really trying to take advantage of text to make inferences and predictions. We are now looking at merging structured and unstructured data. So in that electronic health record context, like I said, we do definitely want to have structured data in there, and we want to take advantage of it. But can we combine the structured data that's in there with the more nuanced information that's in the unstructured data in order to build a better representation of what's going on with the patient? Other areas are things like anomaly and fraud detection. So there is work that tries to identify deception and things like that. And so if you look at tweets, we have issues like sarcasm and so forth, which make that hard. But we want to try to find, certainly the intelligence officials would like to try to be able to identify people who are using their words to try to deceive. So we have tons of text and tons of gold in that text. All right, I'm going to give you another joke in my weird linguistic way. Okay, an MIT linguistics professor was lecturing his class. In English, he said, a double negative forms a positive. However, in some languages, such as Russian, a double negative remains a negative. Okay, so what is a double negative? The prof was not uncertain. So that means he's certain, right? So not uncertain is the same as certain. That's what a double negative is. This will help you understand the joke. But there isn't a single language, not one, in which a double positive can express a negative. You ready for the punchline? A voice from the back of the room piped up, yeah, right. And I have to give my daughter credit for running cat interpretation. So, this, again, sarcasm, tough, right? Okay, so I'm going to leave you with this thought. Text is more than just words. A lot of our models really do boil down to just looking at the words. If we can do a little bit more than that and try to contextualize those words and try to make sense of those words in terms of how the humans are intending to communicate, we can get a lot further. And that's, I think, it. That's all I have to say.